Hello, Professors Luis Carlos and Bilal. I am Victor Cornejo, and my peer is.
Mohammed Alshawwaf.
And today we're going to present our activity number 2, which is the automatic control loop with PID controller. In this activity, we designed a PI and a PID controller for our second order system. Now, first, to design these controllers, we first need to obtain the values for our proportional, derivative, and integral components. For the PI controller, we just need to find the proportional and integral. For this, we use the Ziegler-Nichols method. And for the PID controller, we use the pole compensator method to find the proportional, integral, and derivative values.
So after calculating the values of our system, we find KB and time integral. We use both of them in our PI controller. We use the values in Volstad and Simulink. And Volstad, like we see, we create a circuit, and in Simulink we use a system. So we have the block of KB and integral and the system. So we obtained, we start the simulation and we obtained this graph and this response in Volstad and Simulink. Like we see, they are similar together. In PID controller, they are similar with the PI, but the difference is we bought a new component. It is the derivative one. So in full start, like we see, and in Simulink, like we see, we bought a new component. That's it.
These were the graphs
After
obtained.
running,
We run the simulations, and these were the graphs we obtained. They're pretty similar, although a slightly bigger overshoot in the Volstad method. Now, we wanted to test the systems with the disturbance. For the PI controller, we used a 1 volt disturbance, and we tested how it performed. The disturbance, we inputted it as a step function, adding the 1 volt difference, and we test how much time it would take the system to recover this set point. For the PID controller, we did the same. We used the step function to input into the signal a 1 volt disturbance, just like the PI controller, and we tested out how fast it will recover the set point. After all the tests were done in both the PID controller and with and without a disturbance, this is the performance of both systems. The PI controller had a much bigger max overshoot than the PID controller, nearly 4 times higher, a 22% versus a 6% in the PID controller. The settling time was nearly 2 seconds faster in the PID controller. The steady state error was the same in both, a 0 volt steady state error. Now, with the disturbance, the percent deviation was nearly the same, a 22% deviation with the PI and a 20% deviation with the PID. But the PID did recover the set point faster after that 1 volt disturbance, 4.7 seconds for the PID as opposed to 6.3 seconds for the PI controller. So that was all the work we did for the second activity. It was a pleasure working with my peer Alshawwaf, and I hope we can work again soon.
Yeah, it was a good experience, and I had the pleasure of going through it. We hope to do it again and see you again.
Thank you, professors.